Right, so this is OCR's paper 5 from November 17. It's the non-calculator paper, and you'll see we need 12 marks for a grade 4, 23 marks for a 5, and so on. So question 1, we're just looking for parts of a circle, and the first part is line A, which is this line. That is a line that touches the circle but never enters it. That is called a tangent. Part B, shaded region B, that's just called a segment. Question 2, we're looking for the next term in each of these sequences. Well, we can hopefully see that this is a Fibonacci sequence. 1 add 1 comes to 2. 1 add 2 comes to 3. 2 add 3 comes to 5. So these previous two terms, 5 add 8, will add together to make the next term in the sequence, and 5 add 8 is 13. Different type of sequence here, from 2 to 4, 4 to 8, and 8 to 16. I think we're just doubling, so we need to do 64 times 2. Well, 2 60s are 120, and 2 4s are 8. Part B, we're looking for the nth term, or the nth term expression. If it's not obvious what's happening with the sequence, just check what's happening between each term. 15 to 12 is take 3, 12 to 9 is take 3, and 9 to 6 is take 3. If you write minus 3n, you've got the first of these two marks. The second mark would come from imagining a term there and figuring out what this term is. If we just go that way, rather than taking 3, we're adding 3, and 15 add 3 is plus 18. Question 3, quite a lot of information, but it's all just types of number. We're looking for a number between 1 and 150. It has to be one more than a square number. So what I'm going to do is write down my square numbers first. And your square numbers come from 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9. And I'm just going to carry on that pattern. I'm stopping at 12 12s because my number needs to be less than 150, and I know 13 13s is 169. Now I actually want one more than a square number. So what I'm going to do is add 1 to each of these. We can then move on to the next bit. The next part says 3 less than a cube number. So I'm going to start by writing down my cube numbers. They come from 1 times 1 times 1. 2 times 2 is 4 times 2 again. 3 times 3 is 9 times 3 again. And I'll just carry on with that pattern. Again, stopping at 5 times 5 times 5 because I know 6 times 6 times 6 will be bigger than 150. Don't forget we need 3 less than a cube number. So I'm going to subtract 3 from each of those, ignoring the first one because my number has to be between 1 and 150. So minus 2 is no good. Take 3 from this. Take 3 from this. And what we're looking for is a number that's in the blue list and the pink list. Well, 5 is in both lists. And 122 is in both lists. That should have been 122 there, apologies. Just change that now. So it's either 5 or 122. Fourth part of this problem says not a prime number. Well, 5 is prime. 5 will only divide by itself and 1 exactly. So it can't be 5. The answer is 1, 2, 2. Question 4, we're factorising. And what we've got is a square number and a square number. X squared is a square number and 43 squared is a square number. You've got two square numbers with a subtraction between them. How to factorise this is to open up some double brackets. Take the square root of x squared. Well, the square root of x squared is x. Take the square root of 43 squared. The square root of 43 squared is 43. Put an add in the first bracket and a subtract in the second bracket. Part B is exactly the same. We've got a square number, and a subtraction between them. So I'm going to follow the exact same skill. Take the square root of 57 squared. Take the square root of 43 squared. put an addition between these and a subtraction between these. Just look up the difference of two squares if you're not sure what I'm doing here. Because we've got pure numbers here, we can actually work these out. 57 add 43 is 100. 57 take 43 is 14. And remember, when you've got double brackets, you've got a multiplication. So this is 100 times 14. Well, 14 times 100 is 1400. Question 5, we're looking at two triangles. And what we're asked to do first is draw the image of triangle A after a reflection in the line y equals -1. Well, here's my y-axis. Here would be y equals -1. No, -1, -2. So this is the line y equals -1. So many people draw that up and down to follow the y-axis. It cuts through the y-axis, y equals -1. We're then going to reflect this triangle in this line. All we need to do is pick a point, 1, 2, count to this line, and 1, 2, same on the other side. Pick a different point, 1, 2, and same on the other side. This point here would be 1, 2, 3, 4, 5 to the line. So 1, 2, 3, 4, 5 on the other side. Connect those together. That is your reflection. Part B, we're describing a single transformation that maps A onto B, where we can see that this has definitely got smaller. Okay, so you would get a mark just for writing the word enlargement. Even though it's got smaller, it's still an enlargement. We can see that it was 2 squares across, and now it's 1 square across. So we can write scale factor equals 1/2. And the final bit of this question is to find the centre of enlargement. Well, if we connect matching points together and then keep going, so I'm going to go just like that, connect these two and keep going, and same with these two, and you will see there is a point where these lines all match, all cross over each other, and that coordinate there across to 5 up to 7 is the 0.57. Part C, complete this statement. A rotation of 180 degrees around 0, 0 has the same effect as an enlargement by... Well, if I did that on shape A, I'd get the following. And what this is an enlargement through this centre, and the scale factor is -1. If I do the same thing I did up here, pick that point, connect them together, pick that point, connect them, this point and this point, connect them, you'll see all 3 lines go through 0, 0. So that's why my centre is 0, 0. The -1 scale factor is this perfect reversing, if you like. It's called an inversion. So that's your scale factor, -1. Question 6, we're looking at a rectangle. We've got algebraic measurements on there, and we're told that the perimeter is 46. So we know that all 4 sides added together comes to 46. So don't miss out the sides that aren't included. If that's 4x minus 5, that's 4x minus 5. And if this is x plus 3, this is x plus 3. And the perimeter is all these added together. So I'm just going to write that down. I'm going to say and because we're actually given the perimeter is 46, we can say that that all equals 46. I'm going to simplify the algebra on this left-hand side. I've got 4x, 8x, 9x, 10x's. We've got -5, -5, that's -10. Then add 3, so add 6 would be -4 altogether. still equals 46. Solve this equation. Add 4 to both sides. And divide both sides by 10. And we get x is 5. Now we're not quite finished because we're not looking for x, we're looking for the area of the rectangle. And area comes from base times height. So what I'm going to do is put x into this. So when you've got 4x minus 5, you've got 4 times 5, 4x's, minus 5. 4 5s are 20, take 5 is 15. And then same over here, we know that x is 5, so 5 add 3, that's simply 8. The area is going to be 8 times 15. Well, 8 10s are 80. 8 5s are 40. Your area is 120 centimetres squared. Question 7, we've got someone who's been given a 10% decrease, and that's taken their wage to 252. Now, if someone's had a 10% decrease, they start with 100%. They've gone down by 10%, so they're left with 90% of their original wage. So what we want to do is turn this back into the 100%. You cannot just find 10% of this and add it on. It's not how percentages work, okay? What we are going to do is turn this 90% into 10%. And we're going to do that dividing by 9. So we've got to do 252 divided by 9. 9 into 2 is 0, remainder 2. 9 into 25 is 2, remainder 7. And 9 into 72 is 8. 10% of her original wage is 28. If we know 10% is 28, we can scale back up to 100% by timesing by 10. And we do the same with the 28. 28 times 10 is 280. That is her original wage. The question actually says, what would her weekly wage be if she'd received a 10% increase? Well, we know she's got 280 to start with. We know 10% of that is 28. 280, add 28 is 308. Question 8 looks at angles in a triangle in the ratio 1 to 2 to 3. And we're asked to show that it's right angled, meaning there must be a 90 degree somewhere in there. Now what we know is angles in a triangle add up to 180. I'm going to divide that by these 3 parts added together. So 1 add 2 is 3. 3 add 3 is 6. So I'm going to do 180 divided by 6. Set that out as a fraction, because then I can just start halving top and bottom. I've got 90 over 3. I can quickly do that. 90 over 3 is 30. Each part of this ratio is worth 30. So this one part will be 30 degrees. These 2 parts will be 2 lots of 30, which is 60 degrees. And 3 parts of 30 is your 90 degree angle. Part B, we're told that the hypotenuse, the longest side of the triangle, is 15. So the hypotenuse is 15. Calculate the length of the shortest side in the triangle. Well, what we know is if our angles are in the ratio 1 to 2 to 3, then our sides must also be in the ratio 1 to 2 to 3. So we've got 1 part to 2 parts to 3 parts. We know the hypotenuse, the longest side, is 15. So I'm going to share the 15 just across that 3 parts. And we get 15 divided by 3, which is 5. Each of these parts is now worth 5. The shortest side is represented by that. Must be 5 centimetres. Question 9. We've got 250 men, women and children on a train, And then we've got two ratios. We've got men to women. And we've also got women to children. So I'm just going to copy those two ratios down using those colours so hopefully you can track what's happening. And we've got two separate ratios with women in the middle. And what we're looking to do is make these numbers match. We can do that quite quickly. If we just double this ratio, we get an equivalent. 4 doubled is 8 and 5 doubled is 10. And so now we've got this matching zone here. We can write a single 3-part ratio. I'm going to write men to women to children. The men is this 8. The women is this matching 10 that we got. And the children is this original 7. This is our combined 3-part ratio from these two individual ratios. We know that there are 250 people altogether, so we need to do 250 divided by these three added together. Well, 8 add 10 add 7 comes to 25. 250 divided by 25 is 10. 10 25s is 250. The actual question says how many men are on the train. Well, what we found here is each part of the ratio is worth 10. For the men, we need to do 8 lots of 10, which is 80. Question 10, we're looking at a quadrilateral, and we're just told that AD equals AB, so this side equals this side. We're told that CD equals CB, so this side equals this side. And we're proving the angle ADC, so this angle equals this angle ABC. Well, if we split this in two, what we've created is two separate triangles, and these triangles must be the same as each other. Okay, we've got two sides that match, a separate two sides that match, and a third side that matches. We just need to write statements to show that these are the exact same triangle. So we can just say AD equals AB, and that's given in the question. We can write CD equals CB, and again that's given in the question. And then we can just put AC is a shared side. What you're looking at is two congruent triangles. They're congruent, which means same, and the reason would be side, side, side. If you've got two congruent triangles, these angles must match. You would probably need to write the words given for full marks. Question 11, we've got our compound increase or depreciation formula, and it's about Amelia buying a car. The expected future value of the car is given by this formula. T is the age of the car in years, and we're asked for the value of the car when new. This initial number is always what you start with. Part 2 says what's the annual percentage decrease for the car? Well, we're multiplying by 0.75, and multiplying by 0.75 is the same as finding 75%. And then it says show that the expected value of the car when 2 years old is 9,000. So we just need to put T equals 2 into this formula. So we've got 16,000 multiplied by 0.75 squared. What we might want to do, because this is a non-calculator paper, is to think about 0.75 as 3/4. And 0.75 squared will be the same as 3/4 squared. And to square a fraction, you just square the top and square the bottom. So rather than multiply by 0.75 squared, I'm going to find 9/16. This has worked out really nice, because to find 9/16 of 16,000, I'm going to do 16,000 divided by 16. Well, 16,000 divided by 16 is 1,000. And then I'm going to multiply by 9. And I should just write that down. Question B, Amelia's got a graph of her car depreciating, and we're explaining why it's incorrect. Well, this graph shows, let's say after 1 year, the value has dropped by this much. After 2 years, it's dropped by the same amount. So this graph is showing the same drop every single year, which is not how this compound increase or depreciation formula works. So you could write something like that. What we would expect to see on this graph is a sharp decrease first, and then that levels out over time. For part C, we've got Amelia assuming that the car will have no value after 20 years. Well, that is only possible if we're timesing by 0. Remember, she started with 16,000, and we're multiplying by 0.75 to the t, where this is now going to be 20. This part here will never be 0. It'll get very close, but it will never be 0. So the value of the car will never fall to 0. Another way of saying that is you've not got a constant decrease. That would be full marks. Question 12 is asking us to turn this fraction into a recurring decimal. We're just going to use division for that. 5/6 is 5 divided by 6. So how many 6s go into 5? The answer is 0. So we're going to need a decimal and some digits to work with. 6 into 5 is actually 0, remainder 5. 6 into 50, well, 8 6s is 48. So it's going to be 8 remainder 2. 6 into 20 is going to be 6, 12, 18, 3 remainder 2. 6 into 20, 3 remainder 2. We've got 0.83 recurring. Part B, turn this recurring decimal to a fraction. We'll just need to follow an algebraic method to do this. We're going to call the number we've given x. That's 0.126666, just the 6 recurring. We can multiply that by 10, and all that happens is the digits move one place to the left. So you get 1.26666. Again, multiply by 10. You get 100x, and the digits go to the left again. 12.6666. And I'm going to go one more time. Again, the digits just moving to the left. 126.6666. And what we're looking for is this pattern after the decimal point to match exactly. You can see we've just got 6s and 6s. If I picked any of these two, I wouldn't get a perfect match in what's after the decimal point. So I'm going to pick these two and do 1000x, take away 100x, and that leads to 126.66, take away 12.66. I've left off all these extra 6s because what's going to happen is they're going to vanish anyway. 6 take 6 is 0. 6 take 6 is 0. 6 take 2 is 4. 2 take 1 is 1. And don't forget the 100. So we've got this subtraction coming to 114. We can go back up here and say, well, 1000x take 100x is 900x. We know that 900x equals 114. 1x, our original number, must be 114 divided by 900. Go back and check the question. It does say lowest terms, so we do need to simplify this. So I'm just going to start halving top and bottom. 114 halved will be 57. 900 halved is 450. 57 will divide by 3 because 5 add 7 is 12 and 12 divides by 3. So this will divide by 3. And I know 57 divided by 3 is 19. 450 divides by 3, that'd be 150. 19 is prime, so I'm going to stop there. Question 13, we're looking at a speed time graph over a 50-second journey. And what we don't know is this starting speed. We're just given that the starting speed is k. The distance travelled during 50 seconds is 1.35 kilometres. So we've got some information. It says work out the average speed during the 50 seconds. Well, we know that the distance is 1.35 kilometres. We know that the time is 50 seconds. So from this, we can work out the speed. And speed is just distance divided by time. Now what I'm going to do straight off, change this kilometres into metres just by timesing it by 1,000. So kilometres to metres times by 1,000, so it'll be 1350 metres. And I'm going to divide that by the time, which is 50 seconds. What we can do is straight away get rid of those two. We've got to do 135 divided by 5. Well, I'm going to change that. I'm going to double top, double bottom. And we'll get 270 divided by 10. It's the same calculation. It's just an equivalent fraction. 270 divided by 10 is 27. That is in meters per second because I did the conversion from kilometers to meters straight away. Part B says work out the value of k. So what we've got is a speed time graph, but we don't know this starting speed. But we do know that the distance covered on the entire journey is 1.35 kilometers. So we know that the distance in this graph is 1.35 kilometers, and the distance on a speed time graph actually comes from the area underneath the graph. So we know that this area is 1.35, and it represents 1.35 kilometers or 1,350 meters. So we need this area to come to 1,350. What we're looking at is a trapezium. So if I sketch it out, we've got this top measurement, which is 40. We've got this side that we don't know. This bottom measurement is 50. And this is not important. We're looking for how do we get an area of 1,350 from a trapezium. Well, the area of a trapezium is going to come from 40 plus 50 halved and then multiplied by the thing we're looking for. So what we've got now is an equation. We also know that the area is 1,350. So we can now solve this equation to find that question mark. Okay. So what I'm going to do is times both sides by 2. 2 times 1,350 is 2,700. The 40 add 50 will be left, but I may as well do that as well. Final step, divide both sides by 90. Do this over. You're going to get 2,700 divided by 90. That is k, or question mark, the thing we're looking for. Well, we can do this and this. And 270 divided by 9. Well, 27 divided by 9 is 3. So k will be 30. Part C, calculate the gradient of the graph in the final 10 seconds of the journey. If you look back at the graph, that final 10 seconds is a triangle. 10 seconds time along the bottom, and we just worked out the height, which was k, which was 30. The gradient is the steepness of this line, which is 30 divided by 10, which is 3. Because we've got a downward sloping line, the gradient would be a negative, so -3 is the gradient. And what does the gradient represent? Well, if the speed is decreasing, then that is deceleration. Question 14, we've got 10 sweets in a bag. We know that 5 are cherry, 4 are lemon, and 1 is orange. Adam's choosing a sweet at random from the bag and eats it. He then takes another sweet at random from the bag and eats it. And he says the probability is 25/100ths, which he's got from 5/10ths multiplied by 5/10ths, probability of cherry multiplied by probability of cherry. But if he eats this first sweet, then there's only 9 sweets left in the bag. So what he needed to do here was not multiply by 5/10ths. You need to say, well, to start with, the probability of cherry is 5/10ths. If he eats a cherry sweet, there's only 4 left. And also there's only 9 sweets left altogether. This is what he should have done. The actual probability, 5 4s are 20, 10 9s are 90. Part B, we're looking for the probability that the 2 sweets he chooses have different flavours. Well, we could have cherry and lemon, cherry and orange, lemon and orange, lemon. It's quite complex to do that, looking at all the different varieties. If instead we look at same flavours, cherry and cherry, well, we just did that up here. That's 5/10ths multiplied by 4/9ths. If we look at lemon and lemon, well, there's 4 lemons to start with out of 10. If he eats one of these, there's only going to be 3 out of 9 left. And then if we look at orange and orange, well, that's going to be 1/10th multiplied by 0. 9s, if he eats this, then it's gone. So we can do that one quickly. The probability of 2 oranges is 0. Probability of lemon, 4 times 3 is 12. 10 times 9 is 90. And we already worked out cherry above. That's 20/90ths. If we add these together, we get the probability of the same sweet chosen. 20/90ths add 12/90ths is 32/90ths. If that's the probability of same, then the probability of different is everything else. So we need to do 1, take away 32/90ths, and that would just be 58/90ths. Question 15, we've got a survey of 200 families about their weekly spending on food. We've got a cumulative frequency diagram. First part of the question says find the median. Well, median is the middle when in order. So we've got 200 people. The middle of that would be the 100th person. Read across to the curve and down. That there is your median. So I'm guessing this is going up in tens, 80, 90, 100. Yep. Interquartile range, well, we need to come up a quarter of the way up this diagram. So if there's 200 people, a quarter of the way up would be 50. Read across and down. We also need to go 3/4 of the way up. For the interquartile range, we need something called the lower quartile, which I've just worked out to be 70, 78. And then we need the upper quartile, which is 3/4 of the way up. So I'm going to read across at 150. And that's coming out nicely at 100. Just reading a quarter of the way up the graph and 3/4 of the way up the graph. And then the interquartile range is going to be your upper quartile, subtract your lower quartile, and 100 take 78 is 22. Okay, part B of this question, which is on the next page, says 15% of these 200 families spent more than £120. So what we need to do is find out how many people spend £120. So I'm going to find £120, read up to the curve and across. And I think that comes out at 182 people. So we've got 182 people. But that is all of these people. So actually spending less than £120. So all these 182 people spend less than £120. So what that means is everybody else spends more than £120. So if there's 200 people altogether, I'm going to do 200, take away 182, which is 18. 18 people spend more than £120. We just need to see if this is 15% of everyone. So 18 out of 200. Do it as a fraction first. That is the same as 9 out of 100. 9 out of 100 is 9%. So he's wrong. Final part of this question talks about another 200 families, but in a different part of the country. And we've got a median of 84. Well, our original median was 90. And then we've got an interquartile range of 28, and our original one was 22. So we've got some figures to compare, and we're asked to just make two comparisons. Two easy marks if you can remember them. First one, just say which is the higher median. The north has higher median. Second mark, you need to compare interquartile range. So we can say north has a smaller interquartile range, but for this second mark, you must say that means they're more consistent. I've just noticed that this is also a 2-marker, so you might want to say that the north has a higher median, so spend more on average. Question 16, we've got two surds, root 12 and root 75, and we're looking to rewrite them to add them together. You cannot add surds that have got different numbers under the square root, so what we need to do is simplify both of these. Root 12 is root 4, root 3, and root 4 is 2. So root 4, root 3 is 2 root 3. We'll do the same for root 75, which is root 25, root 3. Root 25 is 5, so root 25, root 3 becomes 5 root 3. And we're adding these together, so you've got 2 root 3's added to 5 root 3's. You've got 7 root 3's. Part B, 16 to the minus 3/4. What I'm going to do first is raise to the power of a quarter. Because 16 to the power of 1/4 is the 4th root of 16. What number times itself 4 times is 16? Well, that is 2. 2 times 2 times 2 times 2 is 16. So I've dealt with the quarter part. I'm now going to look at this cubing part. So I'm going to take my 2 and cube it. 2 times 2 is 4 times 2 again is 8. So now I've dealt with that. Final step, deal with this negative index. So I'm going to take my 8 and raise it to the minus 1, just that negative part there. And that just puts 1 over 8. That's the reciprocal of 8. Question 17, we're looking to solve an inequality. Well, this is just a quadratic that if that was an equal sign, we'd solve by factorising. So I'm going to just do the same here. I'm looking for two numbers that add to -5, but times to -6. I think those two numbers are -6 and +1. Now, because this is an inequality, I can't just say x equals 6 and x equals -1 like we would if it was an equation. I'm going to quickly sketch this curve. When you've got x minus 6 in brackets, you've got x equals 6 and x equals -1 as roots on this quadratic curve. So where would they be? Well, this is my x-axis. This is approximately -1. This is approximately 6. And this is a positive quadratic, so it's going to give you something like that. And what I'm looking for from this inequality is where the curve is less than or equal to 0. So where does this curve drop below 0? It's all along this part. And all I need is what values of x correspond to this below 0 part of the graph. And what we're going to have is x is anywhere less than or equal to 6, but bigger than or equal to -1. Question 18, we've got an algebraic proof. We're looking at the difference between two consecutive square numbers, and that needs to be always odd. Well, let's take this bit by bit. My first square number can be x squared. My next square number must be the one after this, which is x plus 1 squared. If I've got a number squared, I've got that number with one more added on squared. That's the next square number. And I want the difference between these two things. So I'm going to write just the other way around. X plus 1 squared. The difference is a subtraction. And I'm just going to work this through now. We've got x plus 1 all squared, which is x plus 1 times x plus 1. I'm going to take away that x squared. Now we've got double brackets to expand. Well, x times x is x squared. X times 1 is 1x. 1 times x is 1x. And 1 times 1 is 1. Don't forget to take away your x squared. Tidy all this up. X squared take x squared is gone. We've got 2x plus 1. And what are we actually looking to prove? That this is always odd. Well, anything times 2 is even. And we're going to add 1 to an even number. And you can just say even plus 1 is odd. Question 19, we've got simultaneous equations and we've got quadratic simultaneous equations, or one of them is quadratic. It's actually set up quite nicely because both of these equal to y. So if you've got something that equals y and something else that equals y, you've got two things that are the same as each other. So I'm going to write that down. This equals this. What we can do now is start to solve this quadratic. So I'm going to take 4x from both sides. I'm going to add 1 to both sides. And now we're down to a quadratic with a leading coefficient. So I'm going to need to factorise this, but it's not going to be as easy as a normal quadratic might be. So let's do 2 times 5 first. Then I'm looking for two numbers that add to -11, but times to 10. Those two numbers that add to -11 and times to 10 are -10 and -1. I'm going to use these two terms to rewrite this. So we get (2x² minus 10x minus 1x plus 5. These two terms come from these two numbers. 2x² is just the original 2x². The 5 is just the original 5. I'm going to write that out again and then break it in half. We can now factorise this left-hand side. 2 is a common factor of 2 and minus 10. X is a common factor of x² and x. Open some brackets. 2x times x is 2x². 2x times minus 5 is minus 10x. Over on this side, there's only a common factor of minus 1. Take that out as a factor. Minus 1 times x is minus 1x. And minus 1 times minus 5 is plus 5. This is good. I've got matching brackets. So that's my first bracket. And then the 2x, the minus 1 go into my second bracket. If we take these back up here, we can now say that the first bracket, x minus 5 equals 0, so x must equal 5. And in the second bracket, 2x minus 1 equals 0, add 1 to both sides, divide both sides by 2. They're my x values. We just need to get corresponding y values. Well, if we go right back here, we've got y is just 4 lots of whatever your x is, then take 1. So from first x value, I'm going to times it by 4, then take 1. 4 5s are 20, take 1 is 19. And my second x value, I'm going to times it by 4, and then take 1. 4 times a half is 2, and then take 1 is 1. There's your final answers.